Next, we will introduce our archive software solution. In the previous section, we provided an overview of LTO and its capabilities. To support the smooth implementation of LTO in your business operations, UNITEX offers a specialized archive software solution. This dedicated solution is called UNITEX ArchiveLT. We will now introduce the main features of ArchiveLT in detail, using the actual operation screen to guide you through. Let's now demonstrate how to archive data using the software. To begin, click on Data Archive to start the archiving process. At the top left of the screen, the available drives on the laptop, such as C, D, and L, are displayed for easy selection. From these drives, we'll now select a folder that contains a 5 GB data file and a video and demonstrate how to archive it using the software. The selected data is then dragged and dropped into the Archive Set section located on the right-hand side of the screen. This archive set serves as a workspace where all selected data is grouped and managed as a single unit for archiving purposes. Files and folders can be added to this area, grouped together as one archive set, and saved with a custom name. The archive set can be saved under a custom name of your choice. On the right-hand side of the screen, there is a free word field where you can enter up to 5 pieces of custom information. For instance, you can input video data to indicate the type of content and use a custom identifier like FS01 as your internal data code. It's also possible to enter details such as the department in charge, for instance, technical department, and the name of the person responsible, such as Mr. A. Storing this metadata along with the archive content allows for efficient searching and extraction of specific data when needed. By default, the free word field provides 5 input slots, but this can be extended to a maximum of 15 entries if needed. In addition, users can fully customize the names of each field, such as data type, and define their own selection options to suit their specific needs. Through the configuration screen, users can modify field names and customize selection options, enabling flexible setup tailored to specific workflows, data categorization strategies, and search requirements. Leveraging these customization options helps maximize the value and accessibility of archived data, ultimately contributing to greater efficiency in your daily operations. After creating the archive set in the top right area of the screen, we proceed to select the destination for archiving. The lower section of the screen displays all connected media, allowing you to choose the appropriate destination for archiving. In this case, we'll designate the LTO 8 media named DV808, currently mounted as the L drive, as the destination for archiving. What's important to note is that you're not restricted to selecting just one archive destination. You can assign multiple media to 3 or more at the same time. As a result, the system can flexibly accommodate use cases such as distributing data across multiple media and ensuring redundancy. Now, you might be wondering, why is it possible to assign multiple archive destinations simultaneously? For instance, let's say you have 2 LTO drives connected, each with its own LTO tape cartridge inserted. With this configuration, selecting the 2 media displayed at the top of the screen allows the system to load the data once and write it to both tapes at the same time. In short, this means you can write to 2 LTO tape cartridges at the same time with just one operation. This feature enables you to generate 2 backup copies, one primary and one secondary, at the same time with a single operation. A typical use case would be to store one copy in a secure location within the company, such as a safe, and the other at an off-site facility for disaster recovery purposes. In order to safeguard against risks like earthquakes, fires, and floods, distributing data across multiple storage locations is essential. While you can certainly archive the data in 2 separate operations, this approach takes more time and involves extra steps. This software allows you to connect multiple drives and perform near-simultaneous archiving to several media, supporting efficient and reliable data management. In this way, efficient data writing is another major benefit of utilizing archive software. After selecting the archive destination, the next step is to begin executing the archive job. By clicking Yes on the confirmation screen, the job will be registered in the queue, and the archiving process to the LTO drive will start. When you open the job details, the current progress is displayed in real time, allowing you to monitor the archiving process as it happens. Among the notable features of this archive software is the verify function, which plays a crucial role in ensuring data integrity. For instance, by the time the progress bar reaches 50%, the data has already been fully written to the media. So what does the remaining 50% represent? It's the verification process, which ensures the integrity of the archived data. Verification works by reading the data that was written to the LTO tape and comparing it against the original files, confirming that the contents were recorded correctly. This verification step is carried out automatically by the software, significantly enhancing the reliability and integrity of the archived data. At this stage, the status is shown as verifying, and the comparison between the written data and the original files begins once the progress passes the 50% mark. In this verification step, the software automatically reads the data back from the LTO tape and compares it with the original files to confirm that everything has been recorded correctly. Performance information is also shown on the screen, providing a visual overview of the current processing status. During the copy operation, the red graph indicates the read speed from the local disk, typically a high-speed SSD, while the green graph reflects the write speed to the LTO drive. This example shows that the LTO drive is functioning consistently, maintaining a stable write speed of around 300 megabytes per second. The software is built with a strong focus, not just on writing data accurately, but also on completing the process as quickly and efficiently as possible. While LTO drives are designed with a maximum write speed according to their specifications, actual performance can vary depending on the operating environment and system conditions. To overcome such limitations, the software applies optimized control mechanisms that help the LTO drive operate as close to its maximum speed as possible, ensuring efficient and stable performance. The software incorporates a proprietary buffering algorithm that ensures efficient and stable data writing to the LTO drive. On-screen graphs provide a real-time view of both data input and output activity, giving you clear insight into the ongoing process. If you notice that the archiving speed is not as fast as expected, possible causes may include network bandwidth limitations during file transfer or performance bottlenecks from the source hard drive. In situations like this, the visual graphs help pinpoint where the bottleneck is occurring, making it much easier to identify the cause and take appropriate action. In this way, the software's ability to support performance visualization and optimization stands out as one of its major strengths. When the copy operation finishes successfully, a copy complete message is displayed on the screen, providing clear confirmation that the process was executed properly. Although the confirmation message disappears after a few moments, all details of the archive operation are permanently saved in the database. As a result, you can easily search for and reference past archive records at any time. From a standpoint of archive history management and traceability, this software is built to offer a secure and dependable user experience. Here you can see the history management screen. Using the search function, you can easily display a list of all previously executed archive jobs. As an example, this archive job was carried out between 9:50 and 9:51 p.m. on May 28th, and its details have been recorded and are displayed here. The total processing time was 1 minute and 31 seconds, and the operation completed successfully. The verification step confirmed that all data comparisons were accurate. Thanks to the precise recording and storage of processing details, this system provides peace of mind when it comes to future reviews or audit compliance. In this particular job, the source was a disk and the destination was an LTO drive. The system has recorded that both operations were completed successfully. At the bottom of the screen, you'll find a detailed file-by-file list, where each entry confirms that both the copy and verify operations were successfully completed. In this way, the software goes beyond simply writing data. It reads the data back from the tape and verifies it against the original files to confirm complete accuracy. Since every step of the process is accurately logged, The system provides a high level of assurance regarding the integrity and reliability of the archive data. In this list, you can see detailed records for each file involved in the archive process. In the item name field, you'll find the name of each file, and in the location field, the path to the folder where it is stored on the LTO tape cartridge is recorded. Although the system automatically generates and displays a unique identifier for each file, users also have the option to manually define the destination folder name during the archiving process. For situations where the internal structure of the LTO tape cartridge needs to be reviewed manually, setting intuitive and descriptive folder names in advance helps enhance both visibility and ease of management. Each file is automatically recorded with its last modified timestamp and file size, and a hash value is also generated and stored to ensure data integrity. The hash value is a unique string calculated from the file's contents, commonly generated using algorithms like MD5 to ensure data integrity. This mechanism makes it possible to precisely verify whether files with the same name are truly identical in content. Even many years after archiving, for example, when retrieving a file a decade later, you can objectively confirm the integrity of the data by comparing its current hash value with the one recorded at the time of archiving. In this way, the use of hash values plays a vital role in guaranteeing data integrity and providing a high level of reliability in long-term data preservation. By incorporating these mechanisms, the software ensures the authenticity of archived data and provides robust protection against tampering. In addition to being stored in the database, the processing results can also be exported as a report in text file format for external reference or documentation. Storing the exported text file allows you to present the archive record to others or verify it externally, making it a useful tool for documentation and communication. Because the report is saved in a standard text format, it can be accessed and reviewed on systems without the software installed, making it easier to share information across different teams or departments. The table shown at the bottom of the report is also compatible with spreadsheet applications like Excel, allowing for easy data analysis and further processing. As a result, the archive data can be repurposed in multiple ways. For example, for conducting data analysis or linking with other enterprise systems. As demonstrated, this process enables high-speed, reliable data writing to LTO tape cartridges, while also ensuring that all results are thoroughly documented and preserved. Furthermore, detailed logs are saved as audit trails, allowing for later verification and ensuring compliance with audit and review processes.